Hello, Pre-Calc Honors kids. It's Miss LaFour again, and we are looking at 10.2 phase shift and tangent. So I want you to recall the graphs that we did before with sine and cosine. Do you recognize which one is which? Oh, that's awesome. You are right. This one is your cosine graph. Oh my goodness, that is not thick enough. Let me fix it right quick. Okay. That first one here is our cosine graph. How do you know it's the cosine graph? Because you see it's starting at the max right there, right? And of course, sine is our one that starts at the origin, so it's easy to pick out. Now, on our phase shift here, okay, the thing that we're looking at that's new is basically this portion, or part of this portion. Whatever value is in here tells us how far we're moving it as far as a phase shift. Okay, that's on the x-axis. Remember, we already did this one, and it's surprised I got a K. I've seen it as D in some textbooks, but that basically tells us up, down. Okay, that's pretty easy because we just, go up or down, and we did that in the last lesson. The B, remember, helps us figure out the period. And A, of course, is our amplitude. So actually, I'm going to do this. Absolute value of A is amplitude. You still got to know that. Okay. 2 pi divided by B, whatever the B is there, is our period. That one, of course, tells us up, down. So we're going to say that's our vertical. It's a vertical shift, but it's easy. Okay, so the harder one is our phase shift. Okay, our phase shift. And that's going to tell us left or right. Okay, if we have to move it left or right. So it's a horizontal move. But that it's just a little more complicated. But don't worry, I got you. Okay. All right, so let's look at this first one. Notice that it's got 1/2 x, and that's one thing I do want to point out. Maybe I should go back up here and point that out. Okay, you see how they have the parentheses here, okay? I probably should have did it in red. But if the b is not factored out of this x minus c bit, you have to factor it out, or else that c is going to be incorrect. So, just something to pay attention to, because there'll be one that's not, actually see this one right here, it's not factored out. I have to factor out the B before I can use my C to tell me the phase shift. So just watch for that one. See, on this first one, we're lucky enough that it's already, it's already got the parentheses here. So I know that this phase shift, because it's supposed to be a minus, so this, instead of going right pi over 4 like we would think it is, this is actually left pi over 4. So I'm going to go ahead and put that, left pi over 4. I'm not worried about factoring anything out because it already has it factored out, okay, because there's our B right there. All right, our amplitude would be 1 in this case, since there's nothing there. That means there's a 1. And period, remember, is 2 pi divided by B, and B is 1/2. So that's 4 pi. Alrighty, so let's graph it. There's no up or down, so that means our x-axis is our midline. So cosine starts with our A, or the values in the front, so it's starting at 1. So I am starting at 1, and I'm gonna just leave these as original, okay? Pretend this is 1, 2, 3, 4. Okay, we're gonna leave it like that. So 1 would be here. But, oh wait, no, I can't put it at 1. Normally we start at 1. All right, let me erase that. It's not really, we're not starting at 1. We're starting at 1, but I have to remember to go left pi over 4 for every single one. Oh, okay, I got this. Normally I'd start at 1, but I'm going left pi over 4. So this is my starting point. Okay, so that tells us where we start. We would normally end at 4 pi. Oh man, this is a tough one. Okay, 4 pi is where we end, but then I'd have to go left pi over 4 from 4 pi. However, again, they're only giving us 2 pi. Yuck. Okay, so that's halfway. So remember, with cosine, we start at the top. I'm going to do a little sketch. Go to 0, minimum 0, back to the top. Okay, so that's a normal cosine 1. but we're shifting the whole thing left pi over 4 on our graph. And since they're giving us an extra challenge of only going to 2 pi, that means I'm only doing this part of the graph. So that means at 2 pi, I'm going to be at that bottom point, right? If I start here, the bottom point is going to be halfway. Halfway to 4 pi is 2 pi. That's halfway. So it's going to be the minimum. So I would put a minimum here, which is -1, but I got to go left pi over 4. I know, it's kind of tough. It's okay. We got this. That means in the middle is our 0. So normally that would be at pi, but I'm going left pi over 4. There we go. So that is our 0. So I can go ahead and draw that, kind of sketch it out. There we go. And remember, it does keep going. So over here, if I back it up, this would have been the 0 at -pi, but I'm over pi over 4. So here we go, continue. Oh, that looks not that great, but it's okay. And then at 2 pi would have been the next one, but you had to go left pi over 4, so it's really over here. And voila, there we go. So yeah, they gave us a pretty tough one to do as our example, but that's okay, we got it. Alrighty, so let's look at number 2. Number 2. This one we have to rewrite because we got to factor out the b right here, okay? So this is y equal to -2 sine of 2 parentheses x minus, and remember, if I'm dividing this by 2 to factor it out, if I divide that by 2, I'm getting pi divided by 2. And then, of course, close your parentheses, and you got your -1. So you have to be able to undo that part, like factor out the 2. So I'm dividing both of those terms by 2s to bring it out in the front. Our amplitude is 2, even though I know it's a negative. Period is 2 pi divided by 2, so in this case it's pi. Phase shift, we are going right pi over 2. Because remember, the negative is part of the formula. So if you see a negative there, instead of going left pi over 2 like you would think it would be, it's opposite of that. It's like right pi over 2. Alrighty, so now let's look at our graph. Oh, we got down 1. So let me go and do our down 1. So I'm going to put my new midline here. There we go, down 1. Okay, so that's our new midline. And normally for sine, we would start at 0. So since it's midline, it's down 1, but I got to bring it right pi over 2. So this, oh, it's on top of that. I hate when I do that. It's that is my new starting point. So remember, sine normally goes a hump and a hump, but because it's negative, I got to do the down part first, the bottom, piece, and then the top piece, okay? But that is one cycle. So that means at pi, I'm going to be at the end and starting over. But so at pi here, I'm starting over. But I got to go right pi over 2. All right, so that means this is where I'd be starting over. And then now I have that middle one, exactly in the middle is another 0, okay, so that would be here. So because I have the -2, I go down 2 first, so down 2, and then I would do the up 2. Okay, so there we go. Draw it right out just like that, not so bad. And then, of course, that's one cycle, okay? This is one period. This is the main portion. And we'll change the other to a different color. And then we just continue that pattern on. So 2 down, then 2 up. And they want you to fill up the whole, the whole graph that they give you. So on tests, I will be looking for you to fill out the whole thing. Same thing on your homework. If you want to do it in different colors, so you can visually see easily what the one cycle is, that might be a good idea. Alrighty, so let's see, what's our next one here? Write the equation of the following sine curve. All right, Use a positive leading coefficient for A. Okay, so them telling us this means we have to find a shift that's going to give me a positive A. Okay, and we want the closest one, left or right, from the origin. Okay, sine, remember, starts at 0. First thing I'm going to do is find the midline. So let's see, there's 1, 2, 3, 4, 5, 6 here. So halfway is that's 3. So that means my midline would be here. All right, so I already know I've got a +1 at the end here. But I need to figure out what is A. Well, I know A is 3 because it's up and down 3. But I need a +1, so we need to figure out the phase shift. So remember, sine would have a hump and a hump, okay? That is one cycle. So I need to start at a 0. So I want, at the midline, the 0 basically, the first one right or left from the origin. Okay, so if I'm looking for the origin, I'm going to go right because I like it better. Okay, so that means this spot right here could be a starting point, right? No, that wouldn't be it, Dana. That doesn't work. Okay, that's not, because it goes down first. It needs to be positive. All right, so go back over here. Then that means the first one to make a +0 would be here on our midline, right? And then I'd have a hump up and then a hump down. So that's one cycle. Okay, so that's what I'm looking at to figure out what my equation's going to be. So let's see, let's go ahead and write what we can. We know y is equal to, we know A is 3. I know I've got sine. Let's see, our period. So from here to there, what's the distance? Well, if I did, let's see, the distance here, we're going from pi over 4 to 5 pi over 4. So let's see, that's the same as going 0 to pi and shifting it over. So the period, let me go over here and write it down. This would be 2 pi divided by b would have to equal pi. So b has to be 2. All right, so I have a 2 here. Then I've got parentheses x, and since we went right pi over 4, I have to go minus pi over 4. And then our midline is up 1. Oops, that little piece of graph's in it, but it's okay. All right, there we have it. Yay, I probably need to close this parentheses too. All righty. Now the next part we're looking at is tangent. Okay, so for tangent, remember tangent is sine over cosine. So it's y over x. So when you're looking at these, okay, tangent of 0, that's 0. Tangent of, notice they got pi over 4 here, okay? So we're looking at this value, well, not just this value, we're using those values to find out what tangent is, all the way, you know, like this. This is what we're doing. Okay, we're using those. So this would be 1. Notice at pi over 2, since 0 is x, I mean x is 0, then, and that's the denominator, this is does not exist, D and E. 3 pi over 4, we'd get -1 for tangent. Pi, we'd get 0. And I'm going to keep going. Notice I'm going to this one, and then this one, and then this one, all the way around the circle. And we have 1. We have D and E here, because that one doesn't exist either, -1 and 0. So let's look what that looks like if we actually graph it. So I'm taking the points from that other page. And I'm noticing where it says D and E, that's where the thing does not exist, okay? So that would be at pi over 2. So I'm going to draw an asymptote here, right? I'm just doing a dotted line because that's what it should be. Again, at 3 pi over 2. We saw it does not exist, right? There we go. And if we can, well, let me just do one of these first. Here at pi, it was 0. Then at... And actually it was 0 here, right? Pi over here was 0. This was 1. This was -1, 1. So these actually go like this. It kind of looks like the cubic graph in a way on parts of it. And it repeats over and over. So everywhere you have the pi over 2 bit, you've got an asymptote. It's kind of like wallpaper, like a stamp, okay? It repeats over and over. Yeah, this pattern, it would continue. So I'd have an asymptote there, an asymptote here. There's a bunch of asymptotes everywhere. And it goes up like that, okay, left to right. All right, so that's what our parent function for tangent looks like. Okay, how can it be changed? Well, just like before, if you see this a here, we do know the absolute value of a is our amplitude, same as before. That kind of tells us where that point is on the side of the origin. The b, of course, helps us with our period, but period on this one is always pi, not 2 pi. Because notice the whole thing is between, is a distance of pi. So, you have to go in between the undefined values. So that one is different for tangent. You just have to remember that. Okay, this piece right here, the k, will tell us our up, down for our midline, just like before. And of course, the b helps us with our period. And if you have something here, that tells us our phase shift, our left, right, so that makes it harder. Of course, All right, so let's look at how to graph one that's got all these pieces, or a lot of these pieces, not quite all of them. Notice this is not factored out, so I got to factor that out. So we have 1/2 tangent, and then this would be 2, and then x minus, and if we divide it out of 2, pi over 2. All righty. So our period is pi divided by b. In this case, b is 2, so it's just pi over 2. Phase shift, we are going right pi over 2. Okay, so same thing as before. If you see a minus, it doesn't mean left, it means right, because it's opposite when it's inside there on the x. Alrighty, so now let's look at this. We know that the asymptotes are generally at the pi over 2's. But since we're going right pi over 2, so normally it would be here, I got to go right pi over 2. Oh, well, that's just going to put us here, right? There's our first one. Then we know we have a period of pi over 2. So at pi over 2 is from the distance that the whole thing is, so from asymptote to asymptote. So pi over 2 from there would be here. Here's our other asymptote. So this one's really skinny. Look at that. Awesome. Okay. And then, okay, our inside piece is 0, 0, always on our tangent. Since it's 1/2 is our a, that means halfway in between here, instead of going to 1, we would just go to 1/2. So that's a little bitty thing. Go to negative 1/2. So it kind of is like really skinny. There we go. Not terrible. And then you just repeat it over and over. Once you got 1, you just mimic it and just keep going till you fill up the little page. I'm going to draw the rest of these as quickly as I can. It's not terrible. Once you get the first one, it's not bad at all. All right, so let's see. We're making progress here. There we go. See how quick I can do these. Okay, in the middle. Just takes a little time. Especially when I got so many to do. Alrighty, that looks good. All right, so this is the end of this part of the lesson, but if you need help with this skills review, you can just hang on a little bit. If not, you are done. All right, so skills review. Remember complex fractions, there's a couple ways to do this. You can actually say the top one divided by the bottom, which actually what that means. So this would be 2/5, and then when you divide by 3/10, remember you're multiplying by the reciprocal. You can look to see what cancels right here, and I am going to go to a different color. I can see this 5 will cancel with this 10. So now I can just go straight across and I get 4/3, voila, there we go. Okay, so the next one, 1 over sine divided by 1 over cosine. So 1 over sine times the reciprocal, so this would be cosine x over 1, which remember would give us cosine x over sine x, which we know is cotangent x. There we go. Voila. Okay, so this next one, oh, that one looks a little worse. Okay, so let's see. Cosecant I know is 1 over sine. And I'm dividing by or multiplying by the reciprocal of cotangent, which is tangent. So I'm multiplying by sine over cosine. And, oh, look, the sines cancel out. So that means I have 1 over cosine, which is secant. Well, that wasn't so bad. There we go. Alrighty. Now notice here we have adding and subtracting fractions. When we add and subtract fractions, you need to get a common denominator. So let's see, between 5 and 2, we would have 10. So on the first fraction, we said times 2, so times 2. Here we said times 5, so times 5. So that gives us 11 over 10. That doesn't simplify, so we are done. On the next one, to add these, you need a common denominator, which would be 5 times cosine x. Okay, so 5 cosine x. I know it looks weird, but it's okay. That's what it is. Here on the first fraction, we multiplied by 5, so I multiplied by 5 on the top. Here I multiplied by cosine x, so times cosine x. So that means I have 5 plus cosine x over our common denominator, which is this. And that's actually our answer. We can't simplify that at all. So there you have it. Alrighty, and then this last one, remember this is like over 1. You gotta get a common denominator. Common denominator is sine. So this second fraction already has it, so we're not changing it at all, so I can just leave that. But the first fraction, I'd have to multiply by sine on the bottom. So that means I gotta multiply by sine on the top. So we have sine squared theta, because remember, you can either write that as sine squared theta, or you have to use your parentheses and go sine theta squared, but you cannot say just like this, sine squared, theta squared, because it does not mean the same thing, so don't do that, okay? Alrighty, so that would give us sine squared theta minus 1 over sine of theta. There we go. There's more we can do with this, but you haven't learned the identities yet, so we're just going to leave it just like that. Alrighty, now you're done with lesson or the notes part for 10-2. Have fun working the practice and test prep and application.